Hello and welcome to the lesson. Here we would discuss some of the special HDFS commands which we haven't discussed so far in the course. First, we look at HAR, also known as Hadoop archives. As we have already discussed that lots of small files is not a good case for HDFS, mainly because it takes up the name node's main memory. Although it is to be understood that the small files do not actually take up the complete block size on the disk. That is, if a file is 10 MB and the block size is 64 MB, then the file would just occupy the 10 MB of the storage space. So the issue with small file is that it occupies a name node's main memory, as name node has to maintain metadata for each file. The more the number of files, more would be the metadata, which name node has to take care of. So name node's main memory becomes a limiting factor. Hadoop Archive is a tool which helps in such situations. In addition to this, Hadoop archive files can be used as input to MapReduce programs as well. Let us see an example of Hadoop archives and understand how it works. Just before recording this video, I have created this small file folder on my local system in the home folder. In this, I have created two documents, A file and B file. I'll just do a GPS to check everything is running or not. Yep, everything is running. So now I'll just copy this file structure to HDFS using the command copy from local. Now I'll do an ls to see if the files have been created. So there we see the directory. Now we'll archive this file tree structure. So the command is Hadoop archive -archive name, and at this point we'll hit an enter, and there we get the syntax of this command. So the syntax says that the command is archive -archive name followed by the name of the HAR file, followed by -p, followed by the parent path, followed by the source, and then the destination. So I'll type in Hadoop archive -archive name, then I want the Hadoop archive file to be file1.har. Please note that here we need HAR as an extension, which indicates Hadoop archive files. These are handled differently. These are read and written in a different manner, as we will see. And to differentiate them, we use .har extension. Then -p and the parent path would be /user/nj/, then followed by the name of the directory structure that needs to be archived, then followed by the destination path, which would be /user/nj/. I would press enter at this point and a MapReduce program would be invoked. I'll again do an ls on Hadoop file system and see if the Hadoop archive file has been created or not. So that's the Hadoop archive file. I'll do a ls on Hadoop archive file. So as you can see, there are 4 files that have been created for an Hadoop archive file. First file is the success, which marks the successful completion of an archive command. The part file is the one which has all the contents of all the files concatenated together. The two index files, index and master index, contain the indexes used to look up for the content. Let us do a recursive ls on Hadoop archive file. In order to do so, we'll put HAR scheme so as to specify Hadoop archive has been read. So it displays A file and B file. The twiddle sign are the temporary files that were made when we copied the small file directory structure from the local file system. They were created because we had opened them in text editor. Next, we understand the limitations of Hadoop archive files. First, to create an archive file, you need as much as disk space as the original. Hadoop archives currently do not support compression, so it is like a duplicate file. Second, Hadoop archives are immutable. To add or remove files from an Hadoop archive, you must recreate the archives. Third, if you're reaching the limits of the name node's memory, using HDFS federation would give you a better scope in scalability than using Hadoop archives. Next, we look at another command, distcp. This command is used to copy the files from one Hadoop file system to another. The copying process is done in a parallel fashion. The syntax of distcp is as follows. Hadoop distcp, following it would be the source folder, and after that there would be the destination folder. Name node 1 and name node 2 would specify the name nodes of the different HDFS deployed. This command would usually be used when you are using HDFS federation on your cluster and have 2 or more name nodes on the same cluster and you want to copy from one HDFS to another. I'll close this lesson at this point and see you in the next lesson.